In 5 minutes, we are going to start this particular lecture. So we are going to start the power method. So in many engineering problems, it is required to compute numerically largest eigenvalue and largest corresponding eigenvector. So we require to calculate respective eigenvalues. So last lecture I have shown one video that was related to the eigenvalue, what was required for this kind of engineering problems. So most engineering problems don't require to solve this particular equation, but we require to calculate that particular largest eigenvalue and corresponding eigenvector or corresponding eigenvector is also said to be the largest eigenvalue. Need to learn. So first we have to know what meant by eigenvalues and eigenvectors. So we have seen the characteristic equation for that particular for solving the linear equations. So when there is a lot of linear equation, we require a certain characteristic we need to generate, then only it will be possible. So largest eigenvalue or eigenvector, it will be calculated by simple technique. So we have seen the equation x is equal to b, or this is a certain characteristic equation for the linear equation system. So this kind of equation, is it visible for you? Yes, I think it is visible for you. So A's equation of B is that we have to convert into the lambda x. So this is the lambda called as the eigen values, or corresponding that will be eigenvector. So even if you multiply that particular with axi and lambda axi, it will be 6 lambda axi. So ax minus lambda xi is equal to 0. So a minus lambda I into x is equal to 0. So this is the characteristic equation for the finding the corresponding. So lambda would be lambda I value to be eigenvalues. And corresponding vector can find out by here. Corresponding vectors could be calculated by simple putting the particular values for the lambda. So this equation, suppose A matrix is given, A matrix given, matrix is given. So we have certain matrices there. So suppose we need to calculate A lambda I, and we have to equate that equation with respect to 0. So whatever the equation, whatever the values given, so this is the A matrix, and we need to find the eigenvalue for the corresponding A. Then A minus lambda, 5 minus lambda, 9 minus lambda. That would be this, and that we have to equate the 0. So we have to calculate this particular value, and using this particular equation, it would be considering it is a equation containing the lambda that is equal to 0. And that we have to solve. It would be lambda cube 2 plus lambda square plus lambda equal to 0. Or it could be lambda square plus lambda, or certain constant value would be there, and that is equal to 0. So if you solve this particular equation by using A minus lambda, we can find out the lambda values. So this is a simple technique. This is the technique that we have studied in the particular M1 and M2. Now we have to solve these particular equations for the calculation of lambda by using the power method. So this was the what we have consist of earlier lectures. Or now we have to solve this particular technique by using power method. So power method is one of the technique that we find largest eigenvalue. So our task is finding the largest eigenvalue. Most of the complex engineering problem or certain engineering problem required to calculate only largest eigenvalue. So our task, our problem is to find the largest eigenvalue. So this can be solved. Largest eigenvalue can be solved by traditional technique using Ax is equal to lambda x. So that will be converted. Ax is equal to lambda x. So this will be the equation that would be required the eigenvalue for the regular method. So using the regular method, A minus lambda I x is equal to 0. So we have to convert this equation A minus lambda I is equal to 0. So that we have to calculate the lambda values. So these are the eigenvalues. For corresponding vector would be find out by using the x value. So corresponding vector would be easily find out if you find out the lambda value. Certain engineering problems require this kind of eigenvalues and eigenvector. Okay, so we have to study one of the computational technique or numerical method. One of the numerical method that will find out the particular eigenvalues. So here it is somewhat complicated. When we build this particular equation A minus lambda I is equal to, if you convert this equation, the equation becomes complex. This equation becomes complex. It is not easy to solve by using the regular technique. You can solve. It is not like that you cannot solve this particular equation, but it is now difficult to put this particular equation, this particular determinant, and make this particular equation solve the lambda. So again, we require another technique to solve this particular linear equations. So not linear, it would be non-linear equations. So this equation again require certain techniques or another techniques to solve the lambda value. So it will be again tedious to use this kind of traditional method. You may have studied this kind of procedure. You may have calculated A minus lambda is equal to 0 and calculated lambda value in a maths, regular mathematics. But it is somewhat complicated. That's why we have to convert to the certain numerical techniques. So in the numerical techniques, one of the popular method is power method. So we are going to study power method. Up to now, I have told you what mean by lambda value, what is requirement, and how it is calculated traditionally. Okay, so we'll move and we'll study power method. If you have any issue, put in a chat box. I think voice is coming. So we'll see power. Where is that? anything you want to discuss with me? Write the problem. We'll take one of the simplest problem. Determine the largest eigenvalue. Determine the largest eigenvalue and corresponding eigenvector of the matrix 5, 1, 2. The question will be find largest eigenvalue and corresponding eigenvector by using power. Okay, so simple technique. Again, we will equate that particular equation. X is equal to lambda x. X is equal to lambda x. Write that equation. This is the A matrix. Obviously, that will be A matrix will be given. This is a I am taking the particular 2 by 2 problem. 2 by 2 matrix. Definitely, most of the time it will be asked 3 by 3 matrix. Okay, so Ax is equal to lambda x. Ax is equal to, is that visible to you? Right from that one again. X is equal to lambda x. So A matrix 5, 4, 1, 2, lambda x. So what we have to consider initially, we have to consider the eigenvector. So we have to assume. So most of the numerical method we assume certain values. काय चौगुले काय प्रॉब्लेम आहे चौगुलेला का ऑन झाले म्यूट करून टाकू त्याला Okay, so we need to find out the particular largest we have to assume the x value. Okay, we need to find out the x value. So equation we have written x is equal to lambda x. We have written a value. Now we have to assume a largest x value. So initial approximation would be 1 0. So we have to consider here, this is the equation. We have to consider we have to assume the largest eigenvector, corresponding eigenvector x is equal to 1 0. You can consider 0 0 also. If it is a 3 by 3 matrix, we have to assume 1 0 0. This is the largest eigenvector. This is the eigenvector. So this is the assumption. So we have to start with first assumption. This is the assumption where we have to start. We need to start from the assumption x is equal to value 1 0. If it is 3 by 3 matrix, it would be 1 0 0. So what is that? This is a eigenvector. This is the eigenvector. We have to assume the eigenvector 1 0 or 1 0 0. A matrix is given. So we have to multiply with that particular A matrix. A with x. A into x. I will write here A into x. A into x. So A into x. X matrix is what? X matrix 1 0. So we have to multiply. So we have to multiply this particular matrix 1 0. So obviously it would be what? 1 0. So it would be 5 into 4. So it would be 5 value. It would be 5. Then 0 plus 0. That means 1 into 5 0. That would be 5 value. Then 1 into 1 0 into 2 0. That would be 1. So this is what? This is the lambda x. This is the lambda x. So we have to find the largest value again from that particular this matrix. This is the lambda x. We have started with ax. We have started with ax. Multiply ax, and that is we have considered x is equal to lambda x. So whatever the result we obtain, we have to consider as a lambda x. So whatever this result is, that is lambda x. That means largest eigenvalue into vector. Largest eigenvalue into the largest eigenvector. So we have to draw the largest value from that particular lambda x. So we have to write 5 and write here 1.2. So this would be what? This would be what? This would be what? 5 if you have drawn. This would be lambda and this would be x square. So lambda I, lambda xi. So 5, 1, 0. So new eigenvector would be what? 1 into 0.2. So again we have to write a into x1, a again same 5, 4, 1, 2. Then new vector we have obtained. This we will consider as a lambda into xi. Lambda into xi. So we have drawn the largest eigenvalue from this uh, particular matrix, and this is largest eigenvector. This would be this is largest eigenvalue. This would be corresponding vector. So new lambda I and xi we got. As lambda I would be 5 and xi would be that vector would be 1 0.2. So again a into xi. What would be 1 2 3. So suppose this is the first time you have calculated lambda into x1. So lambda into x1 would be what? 5 to 4 into 1 into 0.2. Again we have to multiply this. So that would be what? 5 plus 0.4. That would be 5.8. 5.8 into 1.4. 1.4. So this is a new value of it. Again we have to draw. So I will write here 5, 1.2. New value got lambda 1 x1. So again we have to draw 5.8 largest eigenvalue from here. So 1 upon 5.8 divided by 1.4. So that would be near about 0.41. So again this would be new lambda and new xi. So lambda 2 x2. So this way we have to multiply this particular matrix until we got the two corresponding eigenvectors are same. Two corresponding eigenvectors means this particular eigenvectors should be same. This value and this value, it should be same. Up to that we have to repeat this particular procedure. So now I will write this particular part ax2. Ax2 would be what? A matrix, given matrix A into x2. X2 got here 1.41. 5, 4, 1, 2. Again we have to multiply, and again we have to draw. Again ax3, ax4, ax5 until we got corresponding value should be same. Whatever the eigenvector we are writing here, that should be same. Then we have to stop. I think I will write the particular values so that you will got this particular process. I think 5 iterations they have done. Then 1 upon 0.49. I will write the remaining part. 250. 1 upon 250. 5412. 5412. We have to just multiply with the particular A matrix. We have to A with this corresponding vector, new corresponding eigenvector, and we have to multiply, draw the largest value from this, so that we can got obviously 249, 2450, 250. This is not the. So corresponding eigenvector would be 0.25 into here it would be 6. 6 would be there, so that means calculation would be 6 into 1 5. So that would be 1.5. So last answer would be, we can say this is the largest eigenvalue, and this is the largest eigenvector. Simply think on this x is equal to lambda x. So we have to take a as it is x. We have to consider or assume largest eigenvector starting from 1 0. You can start 0 also, but technically most of the time we have to consider this is the largest eigenvalue we have to draw. So assume here one value 1 0, it is 3 by 3 1 0 0, and then we have to multiply with x. Calculate the particular multiplication of these two matrices. Obtain that particular whatever the multiplication in a format of lambda x. So that lambda x would be what it would be, lambda would be largest eigenvalue. So we have to draw from this particular multiplication. So 5 drawn out 1 upon 0.2 out. So this would be the new eigenvector. Again use this eigenvector. Again we have to multiply with a. Each time we have to multiply with a matrix. Again multiplication, draw out the largest value from that particular this multiplication 5.8. Again this would be eigenvector. This would be larger eigenvalue. So vector, again we have to multiply with this a matrix. Again multiplication, draw out the largest value. Again we have to multiply with the largest eigen vector. Each time whatever the largest eigenvector we obtain, that we have to multiply with a. Is it okay if write this particular problem? Think on this. If you have any query, ask me. If you have any question, ask. कॅमेरा जरा ऑफ झाला होता. Okay, we'll start with new problem. We'll take that problem and see. This is one of the most interesting. Just to calculate A to X. So just we have to do this particular process. The part I have explained for the examination. So no need to calculate this particular part. We can do this particular process. We'll take the real problem that will ask frequently in examination 3 by 3 matrix. Find the largest eigenvalue corresponding eigenvector of the matrix. Matrix will be given -1, 0, then -1, 2, -1, 0, -1, 2. These are the matrices to be given in an examination. And they have said determine the largest eigenvalue and corresponding eigenvector using the power method. And they also will take 1, 0, 0 as the initial eigenvector. They have said take 1, 0, 0 as the initial eigenvector. So that means x value is given. X value is given. Light is switched off. Just wait a minute. Wait for 1 minute. We'll cover this particular problem in 5 to 10 minutes. Max 10 minutes. Try to cover this in 5 minutes. Then you can join the practical 11 o'clock, 11:15. Just wait. Just wait for 2 seconds. So the light will come. Okay, we have to start this particular matrix as a A into X, A into X. The matrix given 2, -1, 0, -1, 2, -1, 0, -1 into X. X value we have to take it as a 1, 0, 0. So that multiplication we have to do as 1, 0, 0. So that would be 2, again -1, again it would be 0. Again, the 2 value 1 -0.5 into 0. This would be new lambda x. So this will be largest eigenvalue and this will be vector. So new vector. So now calculate A into x1. This matrix as it is 2, 1 -0.5 into 0. Multiply this, obtain the new value, then obtain this particular. So again, I will write 2 -1, 0, -1, 2 -1, 0, -1. So again, multiply with this 1.50. Calculate this value. I will write this particular value. That will be 2.5, 2 -2 and 0.5. Again, from this particular matrix, we can draw 2.5 is the largest eigenvalue. Corresponding eigenvector would be 1.8 -0.8 and 0.2. Now multiply this again with AX2, the given matrix with this 1, 0.2, 0.8 and 0.8. 0.2. So this would be the largest eigenvalue and corresponding eigenvector. So if you multiply this particular again, would be 2.5, then it would be 2.8 and corresponding 1 -1, 0.14. Calculate this part. Calculate remaining X values. So if be H3, H4, H5, I think up to 6 we require. And I would like to put the final answer 3.41 and 0.74 minus 1.67. Don't have a calculator. If you have a calculator, this would be the largest eigenvector. Largest eigenvector. Why I have stopped this? Because the earlier version or earlier value is the same, 3.41. Okay. 6 and 7 is going to become same. So this will be 3.41, 0.74 minus 1.67. So this value and this value are going to be nearly same. That's why this is a vector. This is a eigenvalue. Most important word, largest eigenvalue. To do this calculation, I should not have given the answer so that I could have expected the answer from you also. I have written this problem, write this particular problem. No you are not replying anything. Nobody has replied today. No reply. If you are listening, at least type yes. If you are listening, I want to see how many people are listening this particular lecture. If you are listening, type yes. Omkar. Have you got this, Omkar? Have you got this particular problem? How many people have got this problem? This is one of the simplest 8 markers frequently asked. You have to just multiply a into x, a into x. This time a would be 3 by 3 matrix, x would be the singular matrix. X would be always singular matrix, vector would be a singular matrix. So obviously it would be very easy to multiply. Okay, very good number of people are listening. Nikhil, Avantika, Purnali, Ashish, Petra, Shubham, Viruddha, Nishka, Pooja. Good, very good. Ajita, Sandeep, Rishabh has also replied. Simple technique. It is asked frequently. These problems are asked frequently. Only you have to do the calculation. Only people forget the multiplication of this particular a into x, a into x, a into x, and when the value comes same, earlier iteration is same. Whatever the iteration currently is there, that if iterations are same, then we have to stop. We have to say this 3.41 will be largest. 3.41 will be the largest value. Now this kind of value are going to come. We have to find this value are same. That's why we say this is the largest eigenvalue. This is corresponding eigenvalue. One of the simplest techniques. Okay, thank you. I'm closing my session.